Hello friends, today we are going to interface the sensor ADT75 with particle photon. For the sensor you can check out our website controleverything.com and let's search into controleverything.com. As you can see, this sensor is a temperature sensor with an accuracy of plus minus 1 degree Celsius and a 12-bit temperature to digital converter. Now for the particle code, you can get inside the resources section of our website controleverything.com, and here is the particle code. You can also check out our GitHub repository, which is the Control Everything community. Now inside github.com you need to search for Control Everything community and then for the sensor, which is ADT75. Now as you can see, this is the sensor, and for particle there are certain instructions. Now first of all you need to set up your particle, and to set up the particle, this is the link and the steps are given in this link. Then you can download the code from our repository, and then you can paste the code inside the online IDE, and then you can verify the code and flash the code, and you can see the output on dashboard, and this is the link to the dashboard. Let's take a look at the code inside particle. Yeah, here is the code. Now as you can see, on the device address, what we have done is we have directly read 2 bytes of data, the temperature MSB and temperature LSB, and then we have converted the data according to the formula given in the data sheet. Then we have put all the output in both degree Celsius and degree Fahrenheit on the dashboard. This is how you do that. Now this is the particle photon module, and this is the I2C adapter that we use to connect to the I2C devices, and we make the connections using this I2C cable. And here we have our sensor ADT75. Now let's make connections between the I2C adapter and ADT75. First let's take a look at the sensor. Now please, while making connections, please make sure that the brown cable of I2C wire gets connected to the ground of the sensor, and similarly for the I2C adapter too. Now after you have done that, you need to insert the particle onto the I2C adapter. This is how you do it. And to power up the particle, we require a micro USB cable. Now this is a micro USB cable to power up the particle. Alright. Now let's first of all take a look at the compilation of the code. Now in a new tab you need to open build.particle.io/build. After you have opened it, what you need to do is, meanwhile it's opening, let's copy the whole code. uh, yeah, so we have copied the code, and then let's go to build.particle.io as I told you before, and it's loaded now. Now let's create a new application by by writing a name here. The name is ADT75. Now it is in the .ino format, which is similar to Arduino. Let's paste the code. You can save the code and then verify the code, and then you need to flash the code. Now while flashing the code, you must wait for the magenta light to appear on the particle, and as you can see, the magenta light was there, and now the code has been successfully flashed. Let's go inside dashboard. For the link of dashboard is dashboard.particle.io/user/logs, and inside this you will be able to see the output. As you can see, the temperature in degree Celsius and degree Fahrenheit. Now if I put my finger onto the sensor, the temperature increases. Similarly, if I remove the finger, it changes, comes back to normal, and then if I do that again, we can see the same increase. Alright, now that you know how to interface the sensor ADT75, let me tell you some of its applications. Well, the sensor can be used for environmental control systems, computer thermal monitoring, thermal protection systems, industrial process control, and power system monitors. You if you have any kinds of doubts, you can go into the contact us section of controleverything.com, or you can even leave your comments in the community portal of controleverything.com. And for more videos and blogs, you can check out our page on hackster.io and instructables.com. Please don't forget to subscribe us on YouTube, and thanks for watching.